So, hello everyone at this beautiful Friday afternoon. Welcome to the new edition of the on-air program on the online format of the Swiss AI Weeks in collaboration with Wildcard Media. My name is Tilman Eberle, but I'm here to introduce Patrick Rozetter, who works at AWS but is here in a private instance for the talk about who's doing a short introduction to agents, tools, and MCP. The session will be streamed, and that's already it. So guys, be excited about the content, and over to you, Patrick.
Thanks a lot. Welcome, everybody. Let me start sharing my screen. All right. And then, okay. Yeah, today we're going to speak about Gen AI in the financial markets and stock markets, portfolio analytics. Quite some time ago, I was involved in developing a portfolio management system in the 90s. It took us 6 months, 1 year, 2 years to build something that we thought was pretty good. But today with agents and Gen AI, I think we can go much beyond the dreams that we had at that time. At that time, we wanted to have real-time news, stock prices, portfolio optimization, performance calculation, and that required a lot of effort. So let's see if and how we could use agents and Gen AI and LLMs to help us build the next generation portfolio management and stock market analysis tools. And this is what I wanted to try out. This is not yet a ready-made product. This is more an experiment that I wanted to share with you. So my name is Patrick Rozetter. You can find me on LinkedIn. All opinions expressed in this presentation are my own. So we're going to look at AI agency stock market portfolio analysis, like I said. I will demonstrate a small prototype. We'll go into a little bit of code just to see how easy it can be to at least play around. So what we will learn today, well, we'll look at a couple of use cases that we can see or foresee for Gen AI and agents in the stock and portfolio analysis area. We'll look at what is an agent. We look at the different framework of Strands. That's the one I know, and that's the one I think is quite easy. It's an open source framework. We'll look at how to integrate tools that will help agents to collect data from the external world. We'll see how to easily define an MCP server that we can use in cloud desktop, for example. And then we'll go through some lessons learned, the next steps and questions, I guess. So a couple of use cases. I don't want to discuss too much about use cases today, but we know that with AI, we can analyze vast amounts of data. We can infer insights from the data. We can gather real-time data, correlate biased data sources, and provide data points for decision-making. And we can provide portfolio insights, can provide analytics, and so on and so forth. But let's go to the experiment. So I wanted to use an agent-based framework to try out what can be done in terms of stock analysis using open APIs like Yahoo, for example. Then see how we can integrate these tools into an agent and use this agent to summarize and get insights. And then I wanted also to experiment a little bit with MCP. But first, what is an agent? The original definition of an agent that was defined in 1995, I believe, by Russell and Norvig, is very broad. So definition is very broad, and even a refrigerator or a fridge can be considered as an agent. That's anything that can react to some kind of input and then act upon the environment. But an AI agent is a bit different. It can pick up a user query, then based on the query, it will start planning different tasks, how it can reach the result. It can use tools and reflect, and then we'll gather all this information before answering the user query. All this using an LLM. At any LLM, by the way, right? It can be OpenAI, it can be Claude, it can be Mistral, it can be Llama. We'll see how. So Strands is open source framework that makes it quite easy, we'll see, to use agents. Basically, it takes an input, user query and context, and then the agent will start reasoning. It will start planning how we want to answer the query. If he has access to tools, we'll select the tools that he needs to use to provide the answer. And then it will execute the tools. It will gather data from the outside world, for example, and then answer the question or answer the user query. So this framework is model-driven approach. So that means that the agent is based on a model. It gets a prompt. It invokes a model. The model can be any model that we know. Then we'll execute tools, and based on that, we'll return a result, like I said earlier. Now, let's look at a short example. So using Strands is quite easy to define an agent. Just have to instantiate the agent and then pass the query to the agent and see what the result is. So I guess you're seeing a small piece of code on my screen. So here, I'm just importing the agent class, and then I'm creating an agent with no specific parameters, then asking the agent to explain me what is Strands agents about. So let's see. So what's happening behind the scene is that the agent is using the LLM to reason and try to answer the question. As you can see, the answer is not that great because probably the LLM was trained before Strands agents existed. So it doesn't really know what the Strands agents is, but it has provided some answer that in that context may not be that relevant. We'll see later how we can improve this using tools. So that's the first experiment with agents, very simple, 3 lines of code. You have an agent, you can ask a question. Behind the scene, it will access a default agent. In my case, it's using Claude 4.0, I believe, but you can replace with OpenAI or Llama or Mistral or local, even locally hosted agent. All right? Now, let's look at something a little bit more sophisticated. We can provide an agent with a prompt and tell him what he has to do. In that case, I'm telling the agent you are a financial analyst. You need to plot a 20 days moving average of closing prices for the past 1 year, and so on and so forth. And in that case, I'm going to give the agent this system prompt to guide its reasoning process. And I will ask for the moving average of Nestle in Switzerland. I just specified Nestle stock in Switzerland because Nestle is also quoted in the US. So I just want to have Nestle stock in Switzerland. So let's look at the short demo. So here, same thing as before. I'm creating an agent. The difference here is that I'm giving the agent a tool, Python executor. That means that the agent will be able to generate Python code, execute the code, and then pass the result back. And we'll see that it's quite impressive. So let's execute here. So you see that is helping me to analyze the Nestlé stock. I haven't told the agent to go to Yahoo Finance, right? He's figuring out by himself that he can access the Yahoo Finance API. Then he's generated the code to generate the charts. And if everything goes well, yeah, it's cool. It's generated the the chart for the Nestlé stock price and 20-day moving average since 2024. That's quite cool. So that means the agent figured out how to get the data. It generated the code to generate the charts. It has figured out how to calculate the 20-day moving average. And the only thing I've done in terms of coding was really to pass the system prompt. Yeah, to give which model I want to use. So, okay, fine. In this case, I use Claude. I can use another one. I even used Claude 3.5, which is the previous model, or previous version of the Claude model. And then I pass the query. I want to know more about Nestlé stock, and that's it, right? So, quite impressive, I believe. So, going back now, we can obviously do more than that. And what I did was to develop a small stock agent that I can ask few questions like, what is the current NVIDIA price? Can you chart the last 30 days moving average? Can you compare different stocks together? So that the first step into a stock analysis tool, if we want, right? So how does it look like? It's quite similar in a sense. I can show it to you here. What I'm doing, I'm defining different tools for the agent. So there's one tool that will get some macroeconomic news, for example, and it's using like Yahoo Finance to get this news. You can get comprehensive financial news from Yahoo as well. I'm also defining a tool to get the full market overview. I'm also defining a tool to compare stocks, still going through the standard Yahoo API. And then in the agent, let me go down. Then I give the agent all these different tools that it will be able to use while reasoning. So get stock data, compare stocks, all the functions that I gave earlier. It will automatically select based on the question. So let me show you how that can look like. I will switch here. So this is a simple terminal-based interface. So here I can say, okay, help, just to see what kind of questions I can ask. So for example, I can say, okay, let's see what's the current price of Apple, so works. So you see that the agent here will use the tool number one, get stock data. We will get the data from Yahoo automatically. Now, it's a bit verbose. It's getting a lot of different information. I asked only for the last price, but it's giving a bit more than that. So the current price must be 241. Maybe I haven't checked, but probably true. Then it gives me as well the 1 year week range. It's giving me the price earning ratio and so on and so forth. So we can ask also market overview, right? What is the market like today? Okay, I'm making a few typos, but that's fine. I can still correct the typos. So here you can see that he's using another tool, the Get Market Overview tool. So it's using tool 2. And then is fetching the different indices to try to figure out some insights. And it's giving me some observation, technology sector strength, NASDAQ outperformance suggests continued investor, blah, blah, blah. So this is the LLM trying to provide a summary of today's market. I didn't check if it's right or wrong. That's just an experiment again. But I chose the potential behind agents. All right. What we can do as well. Okay, sorry, make it maybe a bit bigger here. We can go further than that, right? We can build a complete application. I'm going to show it to you. A complete application that is using the agent, but can also using another agent that I quickly developed for portfolio management and portfolio recommendations. And that's the architecture. So I built a small Streamlit application. Then I wrapped the agent into a function. And this function will use the stock agent to get the stock data, to get the market overview, and then we'll get all the needed information in order to answer a user query. The architecture looks like this. It's a bit small, sorry about that, but we have the stock agent at the out of the small application, but also have I developed a portfolio management system on the side that could also do some portfolio recommendations or risk analysis. So I can give you a little bit of preview how does it look like here. So that's my simple application. So I can ask for market overview. That's what I did earlier. I'm just using the same agent. It's not particularly fast. You can see here behind the scene what's happening. So it's currently fetching the results from Yahoo, then trying to summarize, getting insights, and then finally publishing the results here. Right. I can also do ask question. Same thing I did before. I can get some company news, market overview, and then I try to develop a very simple portfolio management system where I can create some positions, and then based on that, and using the LLM and using different tools, try to analyze the portfolio. Is there a question? I can't see the chat, by the way. So. So here you can see that the agent is using, in fact, 4 tools. It's trying to analyze portfolio diversification. That's a tool that I've defined. It will try to analyze the portfolio performance, then even try to generate rebalancing recommendations. So these are functions that I've defined myself, right? So it's not something that has been generated by the LLM or anything like that. I'm just giving functions to the agent that he can use depending on the task he has at hand. And then he's using a different function called analyze portfolio risk assessment and then generate portfolio optimization suggestion. Now, I'm not saying this is right or wrong. I didn't test it extensively, but you can see, for example, here that of course, I have low diversification. I have only 2 positions in my portfolio. That's not great. But on the other hand, he's telling me that I have a good diversification. So there's a lot of tests to be done still. But I have a high concentration risk. Can give me some insights on benchmark comparison, for example, and give me an overview of the holding. So I used vibe coding, by the way, to generate this application. So that was also a good way to experiment. All right. I hope I don't go too fast. I can show you still. Sorry. I want to show you the code here. So this is the recommendation agent that I was talking about. That is try to recommend some actions on a portfolio. And I mentioned that the tools that have given to the agent that he can use when analyzing a portfolio. So for example, portfolio diversification, portfolio performance, and these tools are simply, at the moment at least, Python functions. So the only thing I have to do is to use the tool decorator. So basically saying that this function is a tool that the agent, the Strands agent, can use when answering a user query. And I have different functions like portfolio risk assessment, and of course you can code your own rules in these tools, right? And then the agent will use these tools and use your rules to analyze portfolios, analyze stocks, and help on and supporting decision. Now, we're going to talk about MCP. So MCP, okay, MCP, let's go to this slide here. MCP is an open source standard to connect AI applications to external systems. Right? So you've seen an example where I was directly accessing a Yahoo API using a Python function, but we could assume that there could be an MCP server somewhere that would help me to access the Yahoo API. Or you could have an MCP server that would provide me with the access to an external database, to Slack, to Git, to other sources of information. Right? The MCP is just a standardized protocol to allow agents to interact with tools. That's looks simple. So basically, an MCP server has a list of tools. For example, get stock data or analyze the portfolio, and then an application can then ask an MCP server, which tools do you have? And depending on which tools they have, the agent will be able to use the tools of one or multiple MCP servers. So what I'll do, I'll show you how it works here. In my previous example, if you remember, I asked the agent to explain Strands agents, but he didn't know too much about Strands agents. So what we can do is add an MCP server. Yeah. Add an MCP server that is in fact providing information about the Strands SDK, right? So the agent will be able to use a tool that has access to the Strands documentation. So what I'm doing, I'm connecting here to the MCP server, getting the list of tools, and then giving the agent the list of tools that the MCP server has given me. Do it. And you see how now the answer is totally different from the previous one. Because now we have given tools to the agent realizes that he doesn't have enough information by himself, so he needs to use the tools to search for comprehensive information about the Strands agents. So that's basically the idea behind MCP server. We can have decentralized tools. The tools can be hosted locally or they can be hosted anywhere else, and then you can communicate with the tools using the standard MCP protocol. All right. So what I demonstrate now is, in fact, you can also define your own MCP server. That's what I did. You remember that I defined a stock agent function, and I have put this function behind an MCP server. And if you have access to Cloud Desktop, maybe, sorry, I need to show you the Cloud Desktop here. So this is the Cloud Desktop, and you can add tools to Cloud Desktop. So here I have, for example, put my stock info agent. I have added the stock info agent to the Cloud Desktop. And Claude, if I'm asking what is the market overview today, it will realize that it doesn't have access to real-time data, but it has access to the Ask Stock agent that I've showed previously. So the Cloud Desktop will use the MCP server to answer this query. What is the stock market overview today? Provide current market conditions and so on and so forth. And they will use my agent to get the response from the Yahoo API and then summarize it here. That's one way of using an MCP server. So we can integrate MCP servers into Cloud Desktop. The other way is also to start an MCP server locally. So here, for example, I'm going to run my MCP server with the stock agent I've shown earlier. So I'm going to start the server here. So this is an MCP server running on my machine, and then it's going to answer to calls coming through a local port. Here, and here, so is yeah. And here I'm going to run a local application that will call the MCP server. So let me go back here. So what I'm going to do is I have my MCP server that I started. I will start a very simple application that will ask the server, what kind of tools do you have? It will give this tool to the agent, and the agent will then call the tool directly. So let's try it out. So here you see that my application is calling the MCP server. Is calling the ask stock agent, and here the agent will reply back, hopefully soon, if it works. Okay. Not right now. Okay, fine, but you understand me. That's the demo effect. Oh yeah, here it comes. So same as before, it will get the market overview, will get the stock prices. It will fetch financial news from Yahoo and try to fetch news from MarketWatch as well. Okay, there's an error, doesn't matter. And then it will summarize all the insights and send it back to my application here. What is interesting to see is that it's relatively simple to code again. To code. Here, this is the client application. Basically, you see here that I'm connecting to my MCP server. And as I said, I'm asking the server, what kind of tools do you have with this function here? And then I'm just giving my agent the tools that I receive from the server and then asking the server, can you give me a stock market overview? So that's quite straightforward to understand the mechanism. Obviously, there's lots of work to be done, but I wanted to share this simple experiment first. Okay. Lessons learned. First of all, I used vibe coding. I'm not a professional developer anymore. I was a long time back, so I need some help. So I use vibe coding to come up with the application, to come up with API calls and different functions. Second, of course, there's a high risk of hallucination and bias, and we need guardrails. We need to test. This is only an experiment. There's a lot of work to be done to make sure that we stay compliant and we don't hallucinate. That's why we need constant monitoring and feedback loops. We need human in the loop to validate recommendations, for example. We are not yet there to automate the full process. The way to production is still quite long. What I showed today was an experiment. It's not ready at all for any, it's not production ready, that's for sure. Still a lot of fine tuning to be done to get to an acceptable result. That's for sure. So we need to invest time in testing, validating, giving feedback. So what's next? Like I said earlier, it's only an experiment. So we need to integrate guardrails. We need to test, validate extensively. Of course, my user interface is a bit primitive. And then obviously we can add more tools, and we need more tools. We need professional tools. We need more data. We need different sources to avoid bias. Yeah, and I think we are almost at the end. So we have some time for Q&A. Let me see. Is there any question? Yes, there are questions. Let me see. I'm looking at the chat. Will the agent call the tool? Sorry, I can't think. Will the agent? Okay, sorry. Let me go. What? Can you repeat? What's the agent framework you used? Okay, let me show it. This is this one. Can paste it here. So it's an open source SDK. It can use, as I said earlier, it can use Bedrock, Anthropic, Llama, Mistral, OpenAI, Cohere, Llama for local hosted models. So it's model agnostic. Second question, yeah, framework is there. Yes, right. What's the difference between MCP tool and agent tools? In that case, the agent tool are local in the application as a Python function. The MCP can be distributed. So the MCP tools can be defined by somebody else, can be hosted in a different server, can be hosted on the cloud. You can call them remotely. The Strands tools are basically locally defined functions. But conceptually, there's no difference. They are tools basically, right? So there's no major conceptual difference between the two. And from watching this, I remember having seen deploy your own AI hedge fund management team. It's on GitHub. Yes, probably. I'm not the only one experimenting, that's for sure. I'm sure there are people that are much more advanced. I'm doing that on my spare time, by the way. Yes. Are you coding with Python libraries getting from which sources? Well, this one, for example, is totally open source. There's a GitHub. Yeah, okay, you can't. There's a GitHub repo you can just download and install. Here you go. No problem. Pip install Strand agents from here. Will the agent call the tool over the MCP server once provided by MCP, or will the agent call the tool directly by using reference from the MCP? I think it will, if I understand the question correctly, it will always call the tool that is hosted here somewhere in the MCP server. How to find available MCP servers? That's a very good question. I think the whole MCP ecosystem is not yet mature. If you remember CORBA, we still need to have like agent catalog or agent directories that you can call and that will tell you where to find which tools. But somebody has answered in the meantime, do you use AWS tools as well? Of course. But in that case, this is not, you can use any tool. You can use OpenAI, you can use Llama, you can use others. How good is the agent when it comes to interpreting the data it gets from the APIs? That's a very good question. I've seen the agents hallucinate. That's what I said, right? There's a bit of hallucination or really bias. And that's what I said. We need guardrails. We need to validate. We need probably to write down sophisticated prompts to make sure it doesn't hallucinate too much. But to be honest, I was quite surprised by the insight it could give. Is there any use for marketing automation and or increasing the revenue of the business organization? Ooh. Really depends on your use case, to be honest. That's a bit of a very general question. Always start from the problem, I would say. Always try to start from the problem, and if you believe that it can be automated by agents, why not? But start simple. Start simple. You don't always need agents, by the way, so let's be careful. If we don't want to code, I think Zapier, yeah, Zapier probably is doing a similar job. But given that we have vibe coders and, I mean, AI assistants for coding, that's becoming maybe easier to use Python, even for non-professional coders like me. What's the Apply AI community? It's just an online community that I founded to share knowledge around AI, and you can find it on YouTube or on LinkedIn. I interviewed a couple of very interesting people in the AI field, so you can look at YouTube. So I'm doing that just because I like sharing, I like exchanging, I like discussing. I think I've gone through all the questions, hopefully. Yeah. Okay, let's look at there was a question on being skeptical. Let's be skeptical, I agree, always. Of course, if you see the result, they're quite impressive, but we need to be careful, especially in regulated industries like banking and others. We also need to think about ethics and bias. So, yeah. All right. I hope you enjoyed it. And wish you a nice weekend, sunny weekend, hopefully, in Switzerland and elsewhere, of course. Thanks so much. Impressed by the number of people who attended. Thanks a lot.